This is the video for the computer addendum to Kerlinger and Lee's Chapter 16, which will demonstrate the use of Kruskal Wallis test on SPSS. We're on page 425. This all has to do with non-parametric methods, and Kruskal Wallis test has to do with one-way analysis of variance. This is non-parametric analysis of variance. So when we're talking about non-parametric analysis of variance, the Kruskal Wallis test is considered one of the basic forms of non-parametric analysis of variance. It has its own test statistic, which is H, and this text informs us that H is approximately distributed as chi-square. So we'll be using chi-square distribution to determine the significance of the test. We don't see here what the null hypothesis is, but usually when we analyze variance, we look at the means, or in this case it'll be the ranks, the mean ranking. So what the book says is that to show how to use SPSS to analyze data in the Kruskal Wallis test, we created data for a fictitious study. These are the data. In this study, 3 diet plans, Plan A, Plan B, and Plan C, they were compared on the percentage of weight loss. This is the diet type. This is the percentage of weight loss. Table 16.4, which is this, shows the layout of the data. Note that for Plan A, there were 5 participants. 1, 2, 3, 4, 5. 5 participants for Plan A. We had 4 participants for Plan B and 3 participants for Plan C. So this exercise also demonstrates how to compare data when you have different numbers of data points in the groups. And we have 3 groups here. Next, they're telling us figure 16.1 shows how the data are entered into SPSS spreadsheet for analysis. Once again, unfortunately, SPSS doesn't understand the data when it's laid out this way. So what we're going to have to do is to line the data in a way that SPSS can use, and that's how it is. So we have Plan A here with 5 participants. Plan B and Plan C, I'll separate them temporarily just to demonstrate how they were put together. So this is the way I would hope SPSS would accept the data. In the book, they numbered the plans. A was 1, B was numbered 2, and C was numbered 3. I was hoping, which is something I did before, that SPSS will keep the plan names. No, it did not. I eventually did have to go back to what the authors did in the book and assign numbers to the plans. Although, even with numbers, I was able to leave the variable type for the plan as categorical. So this is the way the data are entered into SPSS. Just to demonstrate, we can try to replace the numbers with the plan letters like this. So I'll just clear this one, and then try to to run the test, and this will not be detected by SPSS, unfortunately. Release 10, used by the authors of the book, is no longer available, so the drop-down menu statistics is not available anymore. After transform, we have the analyze drop-down menu. We have to go to non-parametric tests and then K independent samples. What they told us was plan A, people in plan A were given a value of 1 on the plan variable. Plan B received a 2 and plan C received a 3, which is what we're going to do eventually. In addition to the data layout, we also present the ensuing menus and screens when the statistics option is selected. And like I said, this is not going to be statistics, it's going to be analyze. Right here, we have analyze. So we go to analyze non-parametric tests. Now we have to choose K independent samples. After selecting K independent samples, SPSS presents you with a screen where you define your variables. Well, here we cannot define our variables because it can only see one variable, which is weight loss. So I'll have to go back and put the numbers for plan to identify the plan. This is the data layout understood by SPSS. Let's make sure we have, plan is still a string variable type, which is categorical in SPSS lingo. We can now go to analyze non-parametric tests, K independent samples. No, it wants to be numeric. Okay, now we have both variables showing there. This screen asks you to specify which variable is the dependent variable, which we know to be the weight loss, and the grouping variable obviously becomes the plan. Okay, you will need to define a range of values for the independent variable. The independent variable is plan, which is grouping variable. Okay, figure 16.3, which is this, that's what it looks like in the text. Figure 16.3 shows the resulting screen after you have specified the variables. Well, we have specified the variables. Note the independent variable plan has 2 question marks encased by parentheses right here. That's where they are. This says you have to tell SPSS the range of values you have assigned to levels of the independent variable. Well, we'll do just that. Minimum was 1. Maximum was 3. We had 3 plans. We have 3 groups. Okay, and we're making sure we have, for test type, we have selected Kruskal Wallis. H is the test statistic for Kruskal Wallis test. Okay, and abbreviated, okay, just a minute. This is what they call figure 16.5 right here. We can run the test now, they tell us. This is the second run of it. We'll get rid of the first one. Okay, we see exactly what they have showing in their output. They call it abbreviated version of the output. For example, for the significance value, they don't have this HSIMP significance. I don't know what it is. All the other values agree with the screen, and as we see, instead of H, Kruskal Wallis statistic, we have chi-square.
So it's the chi-square statistic that makes the significance level 0.0621. We reject the null. Although we don't know what it is exactly, it's got to be the equality of rankings. So not all rankings are equal. We definitely have differences between the plans. The mean ranks are the same, 7.3, 9.5 is the highest, and 3.25 is the lowest rank. Okay. This is the end of the exercise. In chapter 16 for Kruskal-Wallis procedure, we're going to record another video for Kruskal-Wallis for the Levin book and get some more information about the essence of the test.